In this lesson, we shall talk about the roots of quadratic equations. So when you are given a quadratic equation, such as, let's say, x squared plus 5x plus 6 equals 0, and you solve and you get your two values of x, maybe x equals something and x equals another thing, those answers are what we call the roots of the equation. So always we start from the general before we move to specifics like this. Okay, so let's start from the general. Well, if we are given a quadratic equation like this, ax squared plus bx plus c equals 0, and you are told to solve this equation such that you get x equals something, let's see how we would do that. Well, first, let's talk about only this one, ax squared plus bx, and let's leave c alone. Okay, now the method I'm going to use is what we call the completing the squares. Okay, completing the squares. That's what I'm going to do right now to solve for the x value. Okay, so we have ax squared plus bx plus c equals 0. So I'll factor a out, which means I have x squared plus b over ax plus c equals 0. Okay, now this is true because when I'm moving back to this line, I'll get a times ax squared will give me ax squared. Sorry, a times x squared will give me ax squared. Then a times b over ax will give me bx. So that is true. Then the next thing that we want to do within this bracket is to look for the half of the coefficients of x, and then we square it. Now after that, we will add and subtract so that it will be as if we did not add anything. It's 0. Okay, so that we haven't changed the equation. So that will be a out x squared plus b over ax. Then we take half of this, that will be b over 2a, then we square it. Okay, so now we've added. Now let's subtract the same thing. So we will subtract this plus c equals 0. So the argument I was making was that since we added this and subtracted that, we haven't changed the equations, like we've added 0. Okay, then the next thing that we want to do is to compress from here to there. Okay, and that is what we call completing the square, right? So we have a, okay, so to compress from this side to that side will be x plus b over 2a squared. Okay, so when you expand this, when you expand what we have here, you will get back this. You can give it a try and you see that that is true. Well, now let's deal with this one. So that will give us negative b squared over 4a squared plus c equals 0. So at this time, what we want to do is that we want to use this a to multiply this and then use to multiply that. Okay, so we will get a x plus b over 2a squared, then we will get negative b squared over 4a, okay, plus c equals 0. Then what we can do is that we can move this one here, move that one there. Okay, so that will give us ax plus b over 2a squared equals, then we have b squared over 4a minus c. Okay, well, this means that we can also start to deal with the right hand side. Okay, so that would be b squared minus 4ac all over 4a. Okay, so we have this. Then we can also decide to multiply through by 1 over a so that we get rid of this a. This means that we have x plus b over 2a all squared is equal to b squared minus 4ac all over 4a squared. Okay, then the last thing we want to do is to take the square root. Well, so when we take the square root, we will have plus or minus the root of b squared minus 4ac all over 4a squared. Well, this will give us negative b over 2a plus or minus root of b squared minus 4ac over. Now, if you have root of a over b is the same as root a over root b, okay? Now, since, look at something, root of 4a squared is the same as root of 2 squared a squared, which is the same as 2a all squared. So this square cancels that. So our answer is 2a. All right. Then we put the 2 together. That will give us negative b plus or minus the root of b squared minus 4ac all over 2a. Okay, so when you solve, this is what you have. And this formula has a name. Okay, normally we call it the quadratic formula. The quadratic formula we use to solve most of the quadratic equations that you will see. Okay, and the reason why I said most and not all is that it cannot solve a quadratic equation when under the square root your answer is negative. Let's say negative 10. It cannot solve it. Okay, and I'll tell you why in the course of this study. Okay, so this negative b squared minus 4ac, we call it determinant. Okay, and the reason why we call it determinant is that it determines the number of solutions, okay, or roots an equation has. Okay, and you will soon find out. I have a table to help us understand what we are saying. So we have, let me use light green. So we have this. Now we are using this formula that we got, okay, this formula, and we are using to solve it. Now when we do solve it, look at what is under the square root sign. We have a positive 36, and our final answers were 2 and 4. Don't worry. The next example, okay, we had this. We use the formula to solve it, and what is under the square root is 0. Now we had 2 answers, but the answers are the same, negative 3, negative 3. Now we had our final example, and we use the same formula to solve it, and what is under the square root is negative 20. And the thing is that the root of negative number is not a real number, okay? It is what we call complex number, or simply put, imaginary number. It's not part of the real number system that you know. Okay, so that is why I did not put any answer here. So it has 0 roots. Now, how can we use this to conclude what we've done here? Well, you could see that when this b squared minus 4ac, which is what is inside the square root sign, see, that is what is inside the square root sign. When that thing is positive, you have 2 answers. Okay, you have 2 answers. So we say that these 2 answers are distinct, 2 distinct roots. But when it is 0, okay, when it is 0, we say that you have 2 equal roots, because -3, -3, they are the same. Now, when it is negative, there is no root for you. Okay? Right, so I have a table to summarize all that we've done. Okay, so this is the table. When you have b squared minus 4ac to be positive, okay, that's the first one. That is when it is positive. We are saying that you have 2 real distinct roots. Okay, and it is true because we tested it here. Now, when it is equal to 0, what this means is that you have 2 real equal roots. These roots will be equal, okay, like -1, -1, -3, -3, 2 and 2. The roots are equal even though they are 2. But when it is less than 0, oh no, there are no real roots. Okay, so let's see how we apply this knowledge to solving questions. So we have our first question here. The question reads, and let me change the color, good. It says, find the values of k for which what we have here is equal to 0, has what? This is the most important part. 2 distinct roots. Okay, so you go back. Distinct root means what? Oh, b squared minus 4ac should be greater than what? 0. So it means we are dealing with this one. Okay, so that is what you write first. So for 2 distinct roots, b squared minus 4ac must be greater than 0. That's where you start. Okay, so if you have x squared plus k minus 2x plus 4 equals 0, you can say that b, let's start with a is 1, b is k minus 2, and then c is 4, isn't it? Good. So we can solve for b squared minus 4ac. So that will be k minus 2 all squared minus 4. A is 1, c is 4. Should be greater than 0. Okay, so when we expand this, we get k squared minus 4k plus 4 minus 16 greater than 0. So this is k squared minus 4k minus 8 greater than 0. Okay. So what we do is that you put k here, and then you put another k here. Now the next thing that you want to do is to look for the factors of -8 when added gives you -4. Okay. Well, I think that would be problematic, isn't it? So we can just use our, let me clean this thing. That wouldn't be as easy as I initially thought. So let's solve using the quadratic formula, okay? Remember we got a formula like this. So that would be -b, so that would be 4 plus b squared would be 16 minus 4 into 1 into c, which is -8. Okay. All over 2 into 1. Okay, so that would be 16 minus 4 into -8, and that will give us 48 over 2. So the first answer will be, and then the second answer will be this. Okay, yeah, we can simplify, but like I think we can get the decimal version of it to help us see clearly what we are working with. But I hope we have not made any mistake here. Let me check. B squared is that set. Okay, 4AC. All right, I think we are on track. Okay, so this will be 5.46, or you can just we can write 2.2 plus 2 root 3, or you can just say that it's 5.46, and then this would be, that's 4 minus root 48 over 2. That will give us 2 minus 2 root 3, or in decimal, that will be -1.46. Okay, so when we equate this to 0 and we solve, we are looking at, let's say k is equal to 5.46, and then k is equal to -1.46. Well, this is an inequality, so the best way to solve an inequality is to actually sketch. So we sketch, we don't even need this. You just draw your x-axis, okay, and then remember that the coefficient here is positive, so you have U-shaped, and then we have the 5.4, no, negative first. We have -1.46, and then we have 5.46. Well, the question says that it must be greater than 0. It means we are looking for the positive version. Now, this is positive. Remember, this is x-axis, so anything below is negative, and this is positive, okay? Good, so we are looking for the positive version. That means that we are looking for the part, the x value should be going that way, and the x value should be coming that way. Well, that means that you want k to be what? To be less than -1.46. And here you want k, the value of k, to be greater than 5.46. Now, how do we combine these two? Well, so you can say that, therefore, k should be less than -1.46, or k should be greater than this. right? Okay, so you are good to go. But sometimes you can combine the two and see, well, k should be less than negative 1.46, but k should be greater than 5.46. That is, if you want to write it this way, that's also fine. Now we have another question that I want us to take a look at. Says find the values of k for which what you have has what? Equal roots. Well, equal roots means that b squared minus 4ac should be equal to 0. Well, if that is the case, then you have 4x squared plus 4 into k minus 2x plus k equals 0. This is A, this is B, this is C. So b squared, that will be 4 into this all squared minus 4 into A into C equals 0. Okay, so this means you have 16. Of course, you can decide that what you have here, you can decide to solve it before you apply this. That is fine. Any way is good. So you have this, then 16k equals 0. Well, 16 is common to both sides, so I can factor 16 out, and that would be k minus 2 squared minus k equals 0, which is k minus 2 squared minus k equals 0. Well, at this stage, I think we can expand the bracket, and then we have k squared minus 4k plus 4 minus k equals 0. So this gives us what? K squared minus 4k, no, that would be minus 5k, minus 5k plus 4 equals 0. All right, so we can solve this quadratic easily. All right, so let's see. So we open brackets equal to 0. Then the next thing that we do is that we put k in each of those brackets. So you have k here, we have k there. Then the next thing that we want to do is to look for factors of 4 when added will give us negative 5, and that is negative 1 and then negative 4. So we have k equals 1 or k equals 4. And then we are done. So these values of k ensure that b squared minus 4ac is equal to 0. Okay? Now let's solve another question where the b squared minus 4ac is actually less than 0. It means it has no real roots. Let's see how that is solved. So we have that question right here. Okay, it says find the values of k for which all this has no real roots. Well, that means that for no real roots, b squared minus 4ac is actually negative, is less than 0. Remember, we solved it and we got, I think, negative 20 in the previous example. I don't know if you remember. It's because it's negative. Okay, that means that it's less than 0. Well, if we have 3x squared plus 2x plus k equals 0, that means that a is 3, b is 2, and c is k, right? So we can just put all this into this formula and then solve. So we will get b squared, that is 2 squared, minus 4 into a is 3 into c is k, is less than 0. That would be 4 minus 12k is less than 0. Okay, then the next thing that you can do is to move the 12k to the other side, and that would be you adding 12k to both sides. Okay, so that will be k 4 less than 12k. Then you can divide through by 12. That would mean that 1/3 is less than k, or you can just say that k is greater than 1/3. So that is your answer. So when k is greater than 1/3, you would have what we call the complex roots, because it would have no real roots. Okay. So in our next lesson, I will talk to you about what we call, let me show you, the intersection, okay, the intersection of a line and then a curve. So when a line and a curve, and in this curve, we are talking about a quadratic, okay? When a line and a quadratic intersect, how do we solve? All right, because under normal circumstance, you would be told that, well, solve this simultaneously. But there will be conditions like real roots, distinct roots, and other things. We shall apply what we've learned to how to solve those ones. So look out for my next video